Alright, hey there everybody. It's nice to have you back. I'm Chili, coming at you with another episode of the HUGS Chronicles, and today we are going to continue on our little odyssey into the world of multi-threading. So last episode I talked about condition variables, and today we're going to put that shit into action. We're going to spawn our own thread for the first time. And it's going to do work for us. So let's take a look at the docket. What is up for today? So today what we're going to be doing is we're going to be making a worker thread basically to play Midi files for us. And how we're going to play those Midi files is we're going to use some bullshit called the MCI, which is the Media Control Interface API. And this API came out probably in like the early 90s, in like the Windows 3 point whatever days. That shit is older than the back of Jesus' head, or whatever the saying is. It's older than probably some of you watching this video, and it's a piece of shit, POS. But it has a nice advantage in that it is super easy to use, and I'm a lazy bastard, so that's what we're going to be using. It's not that important. This is not some interesting or some important piece of technology that you need to learn. The cutting edge MCI API. No, this is just some bullshit that I'm using basically to teach you guys how to multi-thread. And because I thought it was interesting, dumb bullshit. And because I want to play a MIDI file in the HUGS engine. So, let's get started. What do we need to use? What do we need to do to use the MCI functions? Well, basically, all you got to do is you got to include system, you got to include Windows, and you got to link to winmm.lib. And you do all that, and, Bob is your uncle, yada yada. Now, how do you use MCI to do your dirty work? Well, there's a function called Mci Send String. It's interesting. You send your commands in text form, and they are interpreted somewhere by MCI, and then they're executed, hopefully. So all you got to do is send in a string, and that string tells it what to do. So here I'm saying play this song, and it's going to play that song. You can put a path in here, a full path, or you can put just a file name, and then it'll use the path that the program is running in. It's not super complicated. So I just got a simple little test project here. This is not part of HUGS. It's just a simple console application is what we got here. And if I run this, I don't know if you can hear that, but it's playing a MIDI file right now. And if I press space, it's going to stop. That's about it. And obviously there's a bunch of different there's an ass ton of commands you can play, or you can do. You can send to MCI. So here is another one here that does the same thing. It plays a song, plays a MIDI file. But this one has a wait appended to it. And what that does is still plays it, but if I press space now, it doesn't stop. I gotta close the program. And so what wait does, if you put that at the end of a command, this function will block until the operation is complete. Whereas other functions like this one, they're actually asynchronous. So when you do MCI Send String, it will spawn a thread to play the song, which is good. So it's non-blocking. And now you can what you can do, instead of just playing a file, you can open a file, you can give it an alias here, and then you can execute commands on that alias. So we can open the file, alias this, and then play that song like that. And if I build a solution, did I change that? Yeah, I just changed to F3. So here I open the file, it should be open right now, and if I press spacebar, it'll play. Press spacebar again, it'll close, there we go. So you can do that, and that doesn't seem to be very useful, except, one thing you could do, for example, is you can open a file. Here we set the time format to milliseconds on that file. So here's the name of the alias. So now we use that alias whenever we want to execute command on the file that we opened. then we can seek to a position in there, and then we can play. And if we do that, let's just build this again. Start. If I press spacebar. And there you go. It starts. And there's some fucked up shit. If you seek, maybe it'll change all the instruments in the MIDI file to be pianos. It's really fucked up. But anyways, it doesn't matter. Because the way we're going to be using it, that's not going to be a problem. Basically, MCI has a lot of fucked up junk in the trunk. But it's not a big deal. We will persevere. So what we're going to do is, well, you can grab the next branch off of GitHub if you want. It's called Midi. And let's get to it. Well, first off, I guess what I should do is I should explain the overall the architecture of the system quickly here. Let's do that. So what we're gonna have, if I can just get it out of this here, is we're gonna have a worker thread, and we're gonna have your main thread, whatever, the thread that's running your game. And well, first of all, the whole reason for this bullshit is as follows: Mci Send String. There's a there's a command in there to wait, right? Tells MCI to block until the command is completed. There's another option that you can have, which is called repeat, and that allows you to loop the playback, but it doesn't work with MIDI. So there is, no repeat for MIDI. There's no sex in the champagne room. And that's a problem. So what we're going to do is we're going to create a worker. And the worker, what it's going to do is when the song is playing, and it reaches the end of a loop section, it's going to seek back to the beginning of the loop section. So it plays from here, and when it reaches here, it seeks back to here, and then it plays, and then it seeks back. So that's what the worker's job is going to be doing, to seek the file when it reaches a certain point so that we can loop the playback within a loop region. That's the whole idea. So what you would think to do is, okay, so your main thread, if you got a class here, and the class is the MIDI file or MIDI song, you're going to have functions in here like, you're going to have the constructor and the destructor, and you're going to have like a play function maybe. And you're going to have a stop. I don't know. Whatever. It doesn't matter. So, the first thing I tried when I was doing this bullshit myself in a different project was I figured, okay, so the constructor is gonna do the open command, and the destructor is gonna do the close command, and the play is gonna do the play command. Whatever. It doesn't matter. And the worker thread, all the worker thread is going to be doing is it's going to be seeking. When you reach a certain time period, it's going to seek back. Now this doesn't work. Basically, for MCI, the thread that opens the file, the thread that calls MCI Send String and with the open command, has to do all the commands. So you can't open up a file or a device, as it's called, in one thread and then use it in another thread, for example, for the seek command. That doesn't work. So that makes our life a little more difficult, because basically what we have to do now is, instead of having a worker that's just seeking and the main thread is calling functions like this, what we have is we have these functions here. And what they're going to do, well, maybe not so much these ones, but what they're going to do is they're going to send messages to our worker thread. And our worker thread is going to have to interpret those messages and do work on them. So, without further ado, let's get to the code. It's code time. Where is my project? Okay, so we've got, let's take a look at what has changed here. So we'll view history, and we'll view the first commit here. So we added a bunch of shit to the project. We added the MIDI file that we're going to be playing. We added midi.cpp, midi.h, and a file called UID Manager. So let's look at that one first. UID Manager, all it does is it generates unique identifiers, basically just unique numbers. And those are going to be used to identify all the MIDI files that we have open. That's it. It's super simple. You can look at it if you want. It's not a complicated piece of code. Let's move on. All right, so MIDI song is the class that, it's going to be doing all our dirty work for us. So what do we got for data? Well, we got a static unique identifier, unique ID manager. It's going to generate unsigned ints that are unique, and those are going to be the ID numbers of our songs that we have open. We've got a mutex, we got a condition variable, as you do when you're doing multi-threading bullshit. You got your ID, you got a couple of flags that are going to be used to signal between the main thread and the worker thread. And you've got a couple numbers here that define the loop portions. The start offset in milliseconds of the loop region and the end offset in milliseconds of the loop region. Now, as for the public interface of this class, you've got a constructor, you got a play command, you got a stop command, and you have a destructor. And you also have a private function here that just generates the alias name. So let's look at that first. I didn't want to. Okay, doesn't matter. We can't toggle because, of course, we're in the view changes bullshit here. So let's take a look at this. Let's go to definition. Here we go. So get alias. All it does is it generates a string, which is chili MIDI underscore plus the ID number. So that's super simple, right? What else do we got here? Well, we've got the commands play and stop. And they're very simple. All they do here is first they check to see if we are already playing, because if you're already playing, you don't want to send the play signal again. That'll just wake up the thread for no reason. So you check to see if you're playing, and then if you're not playing, then you lock the mutex, and you set the shared memory under the mutex, and then you unlock the mutex and you notify the worker thread. Same thing for stop. Here it's the opposite. If you're already playing, or if you're not playing, you don't want to send a stop signal. It doesn't make any sense. So here you lock it, you set the flag, and you notify. And that's it. Now for the destructor, it's a little bit different. In the destructor, we're going to lock the mutex with a unique lock. We're going to set playing to false. We're going to set dying to true. Then we're going to notify, and then we're going to wait on that lock, or on that mutex, however you want to look at it, with the predicate to see if we are not dying. So we'll get into this later, but you're going to wait now for the worker thread to acknowledge that it has received the dying signal and that it will die. And then after it dies, it's going to release the mutex. And then this can wake up again, release the ID that it had been issued from the unique ID manager. And then you can proceed with your program. So this block here is important. You want to make sure that the worker thread dies before you destroy all the memory associated with this object. Because if you don't do that, the worker thread's still working. It's going to try to access memory that no longer exists. And that's never a good time for anyone, now is it? So now let's look at the most important, the most interesting part of all, which is the actual the loop of the thread. So the thread is created in the constructor. Very simple. The constructor gets an ID from the ID manager, and you set the start and end points of the loop. And then you're going to lock the mutex in the constructor. And the first thing you're going to do is create the thread. And all you do to create a thread is you can just call the constructor std thread. And you pass it a function. And in this case, we're passing it a lambda function. And it will execute that function in a new thread. That's very simple. Now the lambda, we want the lambda to be able to access the this pointer and also the path, and the end. End is not so important, I don't think. That was part of something else. We could actually get rid of that, but we don't have to. It doesn't matter. The important thing is that it has access to this pointer and to the path. And so what we do is we lock the mutex, we create the thread, and then what we do, well, we detach the thread, but we'll talk about that later. Just forget about that right now. And then what we do is we wait on the mutex. So now we release the mutex and we wait for a signal. So this is waiting for the thread to finish initialization. So we don't continue in the main thread until the worker has finished its initialization and it's ready to receive commands, which is generally just a good idea. So, in theory, we have locked the mutex and we've created the thread. Now, as soon as we create this thread might start running. The worker might start working. Now, what I want to do is I don't want the worker to do any work until I am ready to wait for the signal from the worker. So what I do is, first thing I do is I lock the mutex here. We're going to have to put a unique lock on the mutex in order to use, the condition variable. So we're going to need to do that anyways. Let's do it right up the beginning. Now we got our two threads synchronized. This thread is going to be, as soon as it starts, its first thing it's going to do is it's going to wait until the main thread has reached this point and has released the mutex, because it's waiting on the condition variable. Once it does this, once the main thread waits on the condition, releases the lock, this thread can start to do its work. And what it's going to do is it's going to initialize a whole bunch of command strings, just generating the command strings from, the parameters, mostly just the alias of the file. And for example, for open, you're going to need the path. And for the seek command for the loop, you're going to need the start point in milliseconds. So it generates all the strings it's going to need, and then it opens the Midi file by calling send string with the open command, .c string. And these parameters here, they're not important. They're just for getting a return value from the function if it can send one. There's the length of the return buffer, and handle to a window that can be used for setting up a callback. So you can actually tell MCI to generate messages, and then you can receive those messages in your message procedure of your window. But we're not doing that bullshit. It's not important, so we set all this stuff to 0 to null. All we need to do is send the command. So we send the open command, we send the set format command that sets the time format. Now we set is playing equal to false. This is important because what I do is I set it initially to be true. So I set the is playing flag to true. But in the initialization part, this actually doubles as a signal to the constructor, the caller of the constructor, that initialization is done. So while is playing is true, let's toggle. Toggle header coder. While that's true, this won't wake up. So this is for protecting against spurious wake-ups, as I've talked about before. So when we set in the initialization, when we set this to false, that's a signal to the main thread that initialization is done. But it won't finish yet until it receives the wake up command, which we then do here. We notify all, and that will wake it up, except it can't get the mutex yet because the worker thread still has the mutex. So it's not going to keep, the main thread isn't going to proceed until we reach the wait command. So we notify the thread, gets it ready to proceed. Then we enter this, this is the loop of the worker thread, and it's going to loop while it's not dying. So as long as it's alive, it's going to keep working. And we're going to set the duration, how long to play, equal to end milliseconds, which is the end of the loop region. So play from the start of the song to the end of the loop region. But we're not going to play yet. That's just setting up this duration variable. And then we're going to wait on the mutex. So we're going to unlock that mutex. And this is the condition to wake up, is either the is dying flag has been set or the is playing flag has been set. Either those flags, if those flags are set, then when this thing wakes up, it's going to proceed. Otherwise, it was just a false alarm and it's going to go back to sleep. So here it sleeps. Now this guy can keep going and proceed on with the program. Now, when someone calls a command, for example, they call play, it's going to set this flag to true, and it's going to notify. And that, excuse me, and that is going to wake this guy up. The condition, because we set is playing equal to true, this lambda is going to return true. This guy is going to proceed, going to grab the mutex and proceed. And then we're going to hit this loop while is playing, and that's going to be true. So we're going to enter the loop, and we're going to send the string, the command to play the MIDI file. And here's where the magic is going to work. We're going to, then again, we're going to wait on the condition variable using our lock. But this time, we're not going to wait for a command or a notification per se. We're going to wait, and we're going to use here, you can add a, well, this is wait for. So you can wait for a specific time, and we're going to wait for the duration of between the beginning of the song and the end of the loop region. And so this condition variable, this wait function will unblock once this amount of time has passed. And then when it wakes up from the end of the passage of time, it is going to seek to the beginning of the loop region. It's going to set the duration now for the length of time between the beginning of the loop region and the end of the loop region, and it's going to play again. It's going to call the play command, and it's going to wait again for the duration, which now is going to be the duration of the loop region. And it keeps doing this for as long as it doesn't get any other input. So this will wake up every time the duration has lapsed, and seek back and play again. Now, while it's playing, you can, for example, issue a stop command, which will set is playing to false and notify all. And when you do that, this will then wake up and grab a little makeup, and then it will it'll seek, not important, it'll set the duration. Then when it hits this while, it'll be, oh, we're not playing anymore. So then it will exit this loop. It will stop playing the song. It will seek back to the start of the song. And then we'll check to see if we're dying. We're not dying. So then we'll reset the duration to from the beginning to the end of the beginning of the song to the end of the loop region. And then we'll wait on another command. So that's what happens when you send the stop signal. It exits this loop, stops the song, seeks the song, and waits for another command. So you got two loops here, the loop and the command loop, which is just waiting for, commands. Then you've got the destructor, which sets playing to false, sets dying to true, notifies and waits on the condition that dying is again false. And what that'll do is, well, imagine the song is playing and we call the destructor. It's going to wake up from the notification. It's going to seek, blah. It's going to check is playing. It's not playing anymore because we set that flag too. So it's going to stop the song, seek to the beginning. It's going to check dying, and it is dying. So now it's going to exit this loop. It's going to send the close command to close the file. It's going to set is dying back to false, and that's the signal to the worker thread that we're done, basically. And then it's going to notify the worker thread. The worker thread won't wake up again because we still have the mutex. And then it's going to exit this thread, which will destroy the unique lock, which will release the mutex, which will then allow this guy to wake up, check that the is dying was acknowledged, and then, release and continue. Release the ID and continue. And that is how she works. That's how the whole shebang works. It's not, I mean, from my point of view here, it's not super complicated, but it might be more, I don't know, it might be more complicated for you if you've never done this sort of thing before. But this is a pretty simple example of how to spawn a thread and then communicate with that thread from a main thread, while avoiding your bad, race conditions, which is different than a race war, but they're both pretty bad. I mean, I'm not going to lie. All right, one point of interest here is, as you notice, all of our all of our, what is it called? Our wait, our calls to, condition variable dot wait. This one here, for example, it's got a predicate here. It's got a condition that'll make sure that we don't continue on a spurious wake up. And let's see, where's the other one? Down here, we also have a condition to make sure we don't continue if it's a spurious wake up. Here we have a condition again, but here in the loop, we don't have the condition. And you might say, oh, that's not very good, Chili, because what happens if you get a spurious wake up on this condition variable? You're just going to continue on, even though the time might not have lapsed or a command might not have been received. You're still going to seek to the beginning of the song and replay. And it's not the greatest. I mean, here with wait for, you can definitely specify a predicate. That's not a problem. You can specify both a duration time and a lapse time and a predicate. But the problem is, if we do that, then what we're going to have to do, for example, if we check the predicate and we find that it is, what are we going to check? Because we'd have to check to see if the amount of time that has elapsed has actually been the duration time that we desire. So we would need to maintain a separate timer so that we can compare the amount of time elapsed to the time that we desired. And if not, then we'd have to reset the duration for the remainder time and then go back to sleep. So in that case, we wouldn't use a predicate. We'd put this thing in a while loop or something. And we just keep waiting until the duration time has fully elapsed or until we actually receive a command. And that's a pain in the ass. Now, there is a function in, in Mci Send String where you can get the current time in the play time. So the current position of the play time pointer. And we could use that, but again, it's still a pain in the ass. I don't want to do that. So let's ask ourselves, what's the worst thing that happens in a spurious wake up? Well, the worst thing that could happen is we didn't have any thread notification, any command, and we're not done our loop. So we're going to wake up and we're going to seek to the beginning, even though we were in the middle of the loop region. And so your song skips. You know what? We can handle that. Spurious wake ups I've never seen one yet. So they're mostly just a theoretical thing for me at this point, although apparently they can occur. So you have to think about them, but think about the worst case. And in the worst case here, it's not so bad. And I'm a lazy bastard, so I'm not going to cover that point. But in general, you should cover your ass for spurious wake-ups by putting in a predicate or something else, checking a condition before just assuming that you received a proper signal before continuing. All right, so that's all she wrote on this motherfucker. I mean, the other stuff that we changed here is where? Yeah, it's gonna be in that in the ship, I guess. Fuck, where is not in the ship, in the screens, in the game screen. So here we added this. This is the header file, isn't it? All right, so we added a Midi song down here. We call it Blasmid because it's from a game near and dear to my heart called Blazing Lasers. And I know, great name, right? So we construct that with these values here. This is the loop region. And what we do is we call the play song when we hit the update and we're not dying. And that allows us to play the song after the countdown, I like that better. And we stop the song if we are dead. So when the ship crashes, the song stops, which is, it's okay. It's good. I like it. And that's it. That's all you really need to do to get the music to play in the game. And if you do that, she will come. Probably not. Sometimes not at all. Oh wait, here we go. Let's try this out and see if the music actually plays. It plays. My ship doesn't move. Probably got the wrong controller. Let's try this one. Nope, just won't move. Still got the keyboard though. There we go. So let's crash this bitch. And there you go. You see the fucker stops. And then you hit the enter button. You'll notice now there's a little bit of a lag between... Let's stop this because it's loud. There's a little bit of a lag between pressing the enter button and the actual screen changing. And that is because loading a MIDI file, it takes a little while. It takes like a few 100 milliseconds. And it's weird. It's one of those fucked up things from MCI. It shouldn't take, hundreds of milliseconds to load a 20K MIDI file, but there you go. So that's that in a nutshell. Now, the last thing I want to talk about before we close off today is I want to just take a little time and explore the reasons why we have all these guards in here. Where did I put the MIDI file? It's right here. I'm going to have to burp again. Oh, shit. That was nasty. Okay. So, why do we have to lock before we create the thread? And why do we got to wait until the end of the thread? Because, there's a thing in multi-threading called pessimism, and that's when you lock up too much, even when you don't really need to, even when, strictly speaking, a race condition cannot occur, but you're not sure, and just to be safe, you add extra mutexes, extra locks and stuff. So it's always good to kind of, think over yourself, why am I doing this? Is this necessary? Now, the first thing I want to say about multi-threading here and locking up and pessimism and all that shit is ask yourself the question, is this part of the code going to be performance critical? Because if it's not, don't worry yourself over locking too much or being too safe, and just fucking do it. Double wrap that Jimmy and just don't worry about it. The more condoms, the better. Just trust me on this one, because then they won't tear. Anyways, never mind. Just forget I said that. That didn't make any sense. Anyways, what I'm talking about here is, so in the beginning, in this constructor here, locking this up here and waiting for the thing to finish here, it's not a big deal because we're in the initialization. If we add an extra, 200 microseconds and we didn't actually need to, do we really care? Just be safe about this stuff, people. Multi-threading can be a super hard pain in the dick if you do it wrong. So just be safe when it makes sense to not cut corners. That being said, let's take a look at some situations, what if we did things different here? So, let's say we don't lock the mutex here, and let's say, oh shit, I forgot, fuck me. Okay, never mind, wind back. There's one thing I didn't explain that I said I was going to explain, and that is the detach call here. And that's actually quite important. When you create a thread, and this is actually, we're not creating like a named thread object here. We just call the constructor. So after this call is finished, the thread will be destroyed, or the object will be destroyed. Now, if you do not call detach before you destroy a thread, if that thread is still running, what'll happen is your program will just crash. It'll just, I'm not even talking about shit the bed. We're talking about apocalypse level shit here. It'll just end your program. So don't call a destructor on a thread object that's still running. And the way we get around that is we detach the actual thread from the thread object. So we call detach. And that means that the thread is now running independent of the STD thread object. And so now if we call the destructor on the STD thread, it's not going to, end our world, which is good. So you got to call detach. If you don't call detach, what's going to happen? Let's just try this. Let's do some science here, people. Science! Let's do that, and let's run this, and we'll press enter, and we'll press enter, and engine has stopped working. Yeah, that's what happens if you don't detach. So there are two things you can do. One of them is called detach. The other one is called join. And we'll look at how you join later on. But I'm just showing you detach right now. So detach will cause this thread to be detached from the thread object. And it's going to be just floating in space doing its own thing. And the way we're going to get it to stop is by signaling it with the is dying thing here. And also signaling it with the condition variable. But other than that, it's completely now detached from, stuff. So detach that's what it does. Now, back to what I was saying. Oh, now my throat is dry again. I do a little dance and then I drink a little water. Back to what I was saying. So let's do some other science here, some investigation. We're going to do a brain investigation. This is going to be a thought experiment. And the reason why is because even if you have a race condition in your code, it doesn't mean that it's going to happen when you run the program. It might only fuck up, 1% or 0.1% of the time, or it might work 100% of the time on Windows 7, but it'll fuck up on Windows 10, or it'll work on a Haswell processor, but it'll fuck up on a Bulldozer processor. You get the idea. So we can't reliably generate these errors. So what we're going to do is we're going to use thought experimentation, just like Einstein did. And he was pretty fucking smart, right? So let's do it. So our thought experiment is we're not going to lock the mutex before we create the thread, and we're not going to wait on this. So let's create a scenario like that. We call the constructor, and then right after we call the constructor, we call play. So let's imagine a scenario here. So you might say, Chili, well, it's okay, because what's going to happen is you're going to call the constructor, and the constructor is going to create the thread, and when the thread starts running, the thread is going to lock the mutex. And while the thread is doing its initialization, even if you call play, you're going to block here until your main thread is done with the mutex and it's ready to receive a command. And I say to you, you're probably right. But guess what? You might not be right. For example, let's say, okay, so you call the constructor and you start the thread. And before the thread gets to locking this up, your main thread somehow manages to call detach and lock the mutex before your worker thread can lock this mutex. So now your main thread gets the mutex before the worker. It sets is playing to true. It calls notify. No one was waiting on that condition variable, so it's ignored. And then the mutex is unlocked. Now the worker thread can continue. And the worker thread, gets the mutex, it initializes this stuff, it opens, sets the format, and then it sets is playing equal to false, negating this command. So even though you created the Midi and then you immediately called the play, that play is going to be ignored because this guy got the mutex before this guy. And although it is not likely, it is technically possible. And to prevent against that, it's nice to lock this up here and then wait on the constructor here so that, what was I saying? Yeah, wait until that so that you get past this point, is playing to false, and so that you are ready to receive a command before you actually continue on in the main thread. And that will prevent a dumb race condition. All right, so let's take a look at some other permutations of this situation here. So we know that we want this situation where the main thread waits here until the worker thread is finished initializing. And so let's try something else. What if we were to put this guy down here, for example? So we wait until after we've done initializing this stuff and opening the MIDI file before we call before we lock the mutex. And this is actually fine. I mean, here we're grabbing the mutex, and here we're waiting. And here, when we run this parallel, we'll do this stuff, and then we'll try to grab the mutex here. And so when we enter this code here, this guy will already be waiting on the condition variable. The main thread will be waiting on the condition variable when we do this code here. When we set that equal to false, and we notify all. And then this guy will get the notification, and then we'll go down here, we'll wait, and then this guy will unblock and continue on. So that's fine. It doesn't matter if you put it at the very beginning or if you put it down here. It might even be a little more efficient to put it down here, because then this guy can be doing this stuff during the time when this guy is getting ready to wait on this. But it's not important. If there is a gain, it's a very minuscule gain, and it's in initialization. It's not a big deal. But this is also perfectly valid. So what if we were to put it here? So now we're going to lock the mutex after we notify this guy. And you might say, well, Chili, I think that will work. And the reason why is because, okay, so this guy is waiting on the mutex. And then we set is playing to false, and we notify. He's going to wake up and continue. He might continue and enter play before we can lock the mutex. It's not likely, but it's possible. But even if he does that, he'll set the is playing message, and when he sets that and then he's finished, this is going to unblock. Not is dying. We'll hit here. We'll hit this, and we won't go to sleep because this flag will already be set. So then we'll enter here and we will play. So even if we call play before we're in the wait for command region here, it'll still work out in the end. But that's actually not true. And the reason why it isn't true is because, first of all, A, the compiler, and B, the processor is free to reorder instructions to make the order of execution more efficient. So even though you write your code like this, where this comes after this, in code, technically notify could happen before this is set. The order could be reversed either by the compiler or by the CPU. And if that's true, if the notify happens while this guy is waiting down here, and it happens before this is set, he's going to wake up, he's going to check, he's going to say, oh shit, it's still not done initializing, he's going to go back to sleep. Then you set the flag, but then it's too late. And then you continue on, and now you're waiting here, and your main thread is still waiting here. You locked up your system, and you're fucked. Effed in the A, as they say. The only hope is to pray for a spurious wake up to unlock you. It's probably not going to happen. So, technically, while this seems like it would work, it actually is not safe because operations can be reordered. And that is why they say you should always modify shared memory under a mutex. Because if you modify this under the mutex, it doesn't matter what order these operations happen in. If the notification comes first, but the is playing is not set yet, this guy isn't going to be able to wake up because he can't get the mutex. The order is you get a signal, a notification, then you get the mutex, you relock, and then you check the predicate. So he won't be able to check the predicate until the mutex is released. So even if this happens after the notification, the mutex is released here, and that is when this is going to be checked. So as long as you modify those shared memory under the mutex, you can assure that this change will be visible to the other thread. And that's what it means to, publish a change under a mutex. Sometimes that's the way people say it. So, yeah, doing it under the mutex is safe. Now let me show you something else. What do you think would happen if we do it like this? So now we set is playing equal to false. Then we do this. then we call notify all. This is actually safe. And the reason is because a mutex, wait, yeah, here we go. A mutex does two things. First of all, it blocks if anyone else is in the mutex, and that's the whole mutual exclusion part of the mutex. That's its most important function. But the other function it has is it is also a memory fence. So whenever you acquire a mutex, that inserts a fence right here. And a memory fence means that operations before and after the fence cannot be reordered. So everything before the fence is guaranteed to happen before everything after the fence. And what that means is that this notify now can't happen before the modification of the flag because we have the fence in between. Acquiring a mutex will give you a fence. So if you like the video, if you're enjoying learning about multi-threading and other anomalous bullshit, that's cool. Click the like button, it helps me out, and it gives me motivation to keep making videos. And I will be back at you maybe next week with some multi-thread optimization, acceleration, whatever you want to call it. We're going to be in there. Until then, I'm Chili. See you later.